Today, we're on the cusp of a new generation of wireless communications called 5G. 5G will support the soaring mobile data and video consumption rates, as well as the Internet of Things that is projected to have billions of connected devices collecting and exchanging data. 5G is expected to support data rates that exceed 10 gigabits per second in certain scenarios and extend the range of frequencies used for mobile communication. This includes new spectrum below 6 GHz, as well as spectrum in higher frequency bands, such as millimeter wave, with specific frequencies at 28 GHz and 39 GHz being proposed. Due to these new frequencies, 5G antenna technology must support millimeter wave, as well as find other ways to optimize cellular networks with new technologies such as beamforming, massive MIMO, as well as improving spectral efficiency with new digital signal processing. The millimeter wave frequency spectrum, which lies between the microwave spectrum and infrared spectrum, offers dramatically wider bandwidths for data transmission than have been allocated in previous generations, but will require new base station designs, radio access equipment, and smartphones that support millimeter wave frequencies. With millimeter wave, propagation loss is greater, and therefore building penetration will be shallower and cell sizes smaller. At these frequencies, antenna elements get smaller, allowing the possibility to pack hundreds of antenna elements or small arrays into a more efficient, single-solution array. MIMO, multiple input and multiple output, is a method for multiplying the capacity of a radio link using multiple transmit and receive antennas to boost end-user throughput and increase that key asset, capacity. MIMO's key features include beamforming, as well as polarization diversity and spatial multiplexing. With 5G, higher frequency bands have relatively large bandwidths, but also greater path losses. Massive MIMO is an effective way to compensate for path loss and to increase peak data rates by multi-stream transmission. For very high frequency bands, the antennas can focus the transmitted energy towards the receiver to overcome increased path loss caused by radio propagation. In plain language, the network antenna beam follows the user. Additionally, the antennas can change the radiating pattern shape and direction, known as beamforming, to better serve a user. These adaptive antennas will utilize MIMO and more complex modulation schemes to increase capacity, improve performance, and improve signal-to-interference plus noise ratio (SINR). By using highly directed beams for 5G phased array communications, electromagnetic interference will be minimized and high data rates will be maintained, even in extremely crowded environments. In addition to millimeter wave, massive MIMO, and beamforming technology, even more capacity and speed can be realized with advances in digital signal processing, or DSP. New adaptive modulation formats are used, as well as traditional quadrature amplitude modulation, now advancing to 256 QAM for 5G for increased spectral efficiency. Digital signal processing, antenna improvements, and MIMO multiply the effect on increased capacity and speed. The 4G throughput target of 1 gigabit per second is now being realized using carrier aggregation and 4x4 MIMO antenna technologies. For 5G, the new target is 10 or 20 times greater. To reach a throughput speed of 20 gigabits per second, larger channel bandwidths are required, and this will require using millimeter wave spectrum in the extremely high frequency range above 6 GHz. At these higher frequencies, operators could see an additional 400 MHz and up to 1 GHz of additional bandwidth, which is significant considering the typical operator has just over 100 MHz of aggregate channel bandwidth today. There will be significant differences in 5G antenna design versus 4G. The interface between the antenna and the radio frequency front end, the use of arrays instead of single antennas, as well as beamforming and massive MIMO. As the world leader in global LTE antenna deployments, the team at Techno has been obsessed with quality and innovation for almost 100 years. Going forward, Techno engineering is focused on 5G with smaller, more efficient solutions, while embracing the 3 pillars of 5G antenna technologies to meet the needs of operators across the globe.
Cut rein, passion to connect.